Alright, so now we have all 6 WANs active here. They're equally load balanced. They're not all the same speed though. It kind of varies, but we're going to run this and just see what it does here. I guess I will start with this. Start this. Does your internet service not give you enough bandwidth to do everything that you want to do? Well, here's a way that you can actually stack up one or more different ISPs and actually get more bandwidth for your house. Now, this is something I'm going to show you. I'm going to actually stack up 6 different ISPs all on one router at my house, and then that's going to share that bandwidth of all 6 of them to all these devices. So you can see I have a bunch of tablets here. I have the kids' tablets, the wife tablet, my tablet. I have a laptop. I have a desktop. You can see just the screen of it on the side of the video here. And then I'm going to have a couple TVs running 4K streaming all at the same time. I'm going to show you the difference in speed I get if I just have one ISP or if I have multiple ISPs. I realize most people are not going to have 6 of them. I just happen to pay for all those so I can do all my testing on my channel here, where I have T-Mobile, Verizon, and AT&T home internet services. And so I figure I might as well have a way to use all of that speed and bandwidth. And so to do that, I bought a TP-Link Omada setup, and specifically I'll go into details of which router I got and how I do it. I'll even show you on the computer here real quickly about how you do this setup to get multiple WANs working, and some of the little tricks that you do have to do sometimes with them. Now, it is not perfect. It does have some downsides. I'll talk about those later. But what I want to show you probably first is just a speed test. So here is my setup. You can see I got 2 Verizon boxes here. I have an AT&T Internet Air. I have a T-Mobile G4AR and a T-Mobile Sagem-Com 5688W. Underneath that is a Chester Cheetah. And underneath that is the TP-Link Omada setup. So that one is the router, and so that is a ER707-M2. So it has lots of ports there. The 2 left ones are 2.5 gig capable, and then the 4 to the right of that are just gigabit Ethernet. But then there's also a gigabit SFP port, which you can see I have an adapter in to have another port. So this thing is fully utilized right now, and I have all 6 WANs in there, and then the white cable that's in the 2.5 gig spot, that one's actually the one that goes down to the switch that then sends out the signal to all the different APs. I have 9 access points throughout the property. Okay, so for the test, what I'm going to do is I'm going to start with a single WAN or single ISP, and I'm going to do a test with a single device. Now, for the most part, it's going to be only that traffic. I have cameras and other things that are running kind of all the time, but it's going to be fairly simple of just that is the only thing I'll be running. And then I'm going to run all of these devices, the 4K TVs, all these tablets will be running 4Ks or speed test, and I'm going to try to be as quick as I can and get them all to run at the same time. And then that will give us an indication of how much my connection slows down, let's say on my tablet or on my computer, when I have all the other devices running at the same time. And then what I'll do is I'll hook up all 6 of the WANs all at once, and we'll do a single device speed test, and then we'll do all of them together. So that should give you a good idea of how the performance can vary between one ISP and multiple ISP. Alright, so this is the single WAN test, and this I'm just going to use my tablet here to see what it gets. So this is on the Verizon box. This is the Verizon Cube. This one I think is the Arcadian one, and it looks like it's going to be about 230. And the other thing I want to watch out for is the ping there, to see how the ping performs with a single device versus multiple devices as well. So you can see we're getting about 230 down and about 20 up. So, or it looks like 25 up. So let's go kick on the TVs, and then we'll click on these tablets and we'll run this test again. Alright, so I have 2 TVs streaming 4K video off to the side. I have these 3 tablets streaming as well. They're not 4K because it's whatever the tablet stream, probably 1080p. Then I have 5 devices here that I'm going to do a speed test on. So I'm going to try to be coordinated here and click as quickly as I can to do all of these all simultaneously. Looks like I did it. It's not the first time I had to redo this shot, but that one's pulling down 100. This one's about 80, 90. This one's only 30. This one's only 9. And so what you're seeing is that it's having to split that bandwidth up, obviously. And now that one started doing upload first, so it went up to 25, but now these other ones are going to start uploading. See, this one's only getting 2. This one's getting only fractional. This one's getting 2. So because that one started first, it got a lot of bandwidth, and then it slowed down to about 14 towards the end. But obviously, when they're all asking for the bandwidth, they can't all get it because they all have to get shoved through that single ISP, which I had about 30 or 33, I think, total upload. So in theory, I think if I add up these, it should add up to that. But let me break down these numbers and make it clear to see what kind of speeds we got across all these devices. Alright, so now we have all 6 WANs active. They're equally load balanced. They're not all the same speed though. Some are slower than the others, especially for upload. Some of them are much slower in upload. But that's the point of this test, is just to see what kind of speed we get overall compared to before. So let me go ahead and start this chain reaction here. Get this all going. And I'm trying to get it as close to the same time as possible. These both are going. This one's doing 300. That one's doing 110. This one's doing about 25. That one's only getting about, it's going up 10, 15, about the same as this one. So these ones start a little bit later. This one's uploading at 47 something. That one's doing about 10. This one's doing a couple at the same time. That one's doing 15 at the same time. So you can see this 40, 15, or 20, and 20. So right there you can see that's a very clear difference. This one's doing about 8 upload, 9 upload. So let me add it together and we'll compare it and see how it did. Alright, so making sense of the data can be a little bit challenging, and I do want to say that it does change. I did several of these tests. Sometimes I had user error of not clicking a start button on one of those, and if you start them out of sync, then obviously they're not all downloading or uploading at the same time. So I did my best to get it as fair as possible. But I will say that you could poke holes at this, and that is fair. This is really just a demonstration of maybe what I saw, and this is indicative of how it performs overall. But just let's dive into the data a little bit here. Alright, so here's the data. I tried to type it in and collect it the best I could, and we'll kind of go into a little bit of what this all means. So let's kind of zoom in here at this table where the single WAN and the 6 WAN. So let me start a little bit with the baseline, which I got about 255 down and 33 up. Then you can see my pings there as well. So that's if I'm just using one device on a single WAN, and that was with my tablet. So the Nate tab is actually what you could compare to that. So that's when I had single WAN still, but I was running all of the devices all at once. If you were to compare it directly, then technically it went down from the 255 and 33 up to 22 down and 22 up. But that is really not quite fair to do that, because I don't even know what WAN that was on when it did that test. It is likely it was on the same one, because I do seem to see that TP-Link will, once your device gets on a single WAN, it kind of favors that one and keeps it there unless it needs to change it for load balancing standpoint. But if we look at these other ones, we got a range of speed. Some of them, my phone got 162, which is pretty good, but it had really poor upload speed. Once I went to a 6 WAN setup, my phone actually got slower than it did previously in the single WAN, but you see my tablet got way faster. In fact, it far beat the baseline, which tells me I was probably hopped on to another ISP service there, and my upload got a lot faster too. So I think that's the one that I have the waveform 4x4 antenna hooked up to. That's the one that gives me really good upload speeds. But if I compare some of my pings, my pings really are not that great, especially for my loaded pings. Even my unloaded has a couple places where it kind of hiccups, but you can see that that happens as well. So Leslie's tablet, for whatever reason, seems to have a poor ping in general. But if we go and compare the total, so this is where I'm adding up all of the download and comparing it between the two. So for the single WAN, it was showing me I had a total bandwidth of about 425. Now, it's not perfect because that is what speed test picked as the bandwidth, and it wasn't necessarily at the exact same instant in time, but it's fairly close. So 425 before. For my 6 WAN, it's 686. So clearly, I'm getting more bandwidth out of the multi-WAN setup, but in this case, it's maybe not quite as drastic as you would have thought it would be. And then for the upload one, it is more drastic. So my upload before with a single WAN is about 40 total concurrent going on, at roughly the same time. Whereas with the 6 WAN, I was getting 117. So that's obviously a big change. That's almost 3 times as much upload bandwidth as I had before. So that one is the more telling one, and that one's the most probably realistic in that some of my other ISPs without the 4x4 external antenna, maybe I'm only getting 5 or 10 for the upload to start with. So to get 117 total, that means it's really combining all of them up there, but not so much with the download. I didn't get 2 gigs of speed download. I was only getting about 700. All right, and then so on the pings, what I did was I said, what's the summation of all of my idle pings, all of my download pings, and all of my upload pings? So I don't know if that's not really a metric, but I'm just curious to see what it was. So what you can see is my idle ping was actually very similar between the single WAN and the 6 WAN, but both my download and upload were significantly higher with my 6 WAN. So that is kind of something I've seen that happens, and that's with this multi-WAN setup. There are some times when I notice there's a little bit of a hiccup when you go send the request before it actually executes that and gets you a response. So I think on this, it actually confuses your device a little bit, and I think it confuses the connection that you have on the internet. And perhaps TP-Link takes a little bit of time to negotiate that transaction as far as what WAN is it going to send it down. But I've seen my device get sometimes confused a little bit if it changes the WAN. So I think that's partly why they don't make it change a lot. But when it does change, then your connection gets swapped, and now you're accessing that site or that server from a different public IP address. So that confuses them because they're like, hey, is this the same person or not? And then your device also kind of trips up a little bit sometimes when it swaps out as well. But again, I would say in general, I don't notice that. That doesn't happen when I'm just using it. It tends to stay on the similar WAN. And then when you have another device that comes on, so like for me, I was doing my speed test. I was doing it, almost at the exact same time. So I was having to manage 5 different requests of full bandwidth all at once, and that's where I threw it for a loop. But if I'm already doing some heavy download and then someone else tries to come on, it's going to automatically send them to a different WAN and not put them on my WAN first. So it might not be exactly fair or representative of what you would get when you're using this in a household environment. Alright, so then the next one I did was the minimums. So I said, okay, what is the minimum download and upload speeds and the best ping I got out of any of these? And this one is also telling because it shows you that the minimum I got for my 6 WAN was much better than what I got as the minimum for the single WAN. So, 3 times roughly better download and upload for my worst device. So most likely that was a device that even on the 6 WAN, it might have been piggybacking on the same WAN as one of the other devices out there. And then if you look at my pings, pretty promising, that both of them actually can get some good pings in there. My upload was a little bit, worse there, 2.5 times worse on my 6 WAN setup. Okay, and then looking out, just a couple different ways to look at the data. You can stack it up for latency. You can see the difference, and this is on the same scale. So it's very clear here that, yep, all my devices on the 6 WAN got worse latency than they got with a single WAN. So there is a clear trend there that multi-WAN, for this situation at least, is adding latency. If I go down to my speed test here, and again I put these on the same scale so that the axes are comparable, and you can look and you can see very clearly that the 6 WAN, obviously it has the strong outlier there in orange that has a really good download speed, but then you can also see that the upload is significantly higher across the board as well. And that's really where it's aggregating my upload, which in some cases is not that great on some of my ISPs, and it's boosting it up so that they all get better performance. So that's how mine performs here. Alright, so let's go into my Omada setup. This is me logging into my Omada controller. So I've typed in my IP address that it is in my local network here, and then I can click on my Nader home here. And then there's a couple things I can look at while I'm in here, and one of them is I can go in here to my devices. I can go to my router, which is the one that's up in the 3rd floor loft that all these things are connected to. Then over here on the side, you can see a few things. One, you can see the first one says it's disabled. That's actually the USB modem, or the USB port for a modem to be plugged into, and that's the only port I don't have active and plugged in. But then you can see my different ports here. This is actually my Verizon one, and you can show that the status is 1,000 megabits per second. So even though it's a 2.5 gig port, that Verizon box only supports a gig speed. So then next is my 2.5 gig capable port, which is the backhaul, or what goes from my 3rd floor loft down to my basement where I have my switch. It's a power over Ethernet switch. And then these next ports 3, 4, 5, 6, and 7, those are all of my other WAN ports out there. And then down here you can also see if they're online or offline, and you can see, like, I gave it like a nickname. So my 2.5 gig is this Verizon ARC. You can also see what the IP address is, and I told it manual DNS servers and that kind of stuff. And it has some other specs down there for you as well. But so you can see what all these different WANs are right here. Now if you want to set your own up, then you go to here to the settings, and then you go to the wired networks, internet, and then by default these are not checked, but so I checked all of these boxes, and what that means is that these are WAN ports. So by default they can be LAN or WAN, and then if you don't specify, there'll be a LAN port other than this main WAN port, which does have to be one. So you can see I have the USB modem disabled, but then all my other ones are enabled. And then in here you can go in and set up these devices. So you can set up DNS servers for each one. You can set up MTU for each one. You can also establish the connection type, and if it's a static IP or dynamic IP. That's one thing you do have to watch out for, because if the router gets assigned the same IP address, then it'll have an IP conflict and it will send an error. So I did have to tell it to get a static IP on this one, and that prevented it from duplicating its IP address that it would get from another T-Mobile gateway, since they all use the 192.168.12.1 as the gateway address. And then for the Verizon one, I was actually able to change it so that the Verizon was on a different, you can go into its settings and actually change its IP address and the IPs that it assigned. So I made sure all that was separate so that they don't duplicate each other. And then if you want to get more complicated on these devices, you can put up a VLAN and actually have them completely separate. I don't do that. I keep them all the same. And then down here in the bottom you have load balancing. So this is where I changed the load balancing. Now for my testing I had it all at 1, but then I switched to this is how I like it actually for home based off the performance I get. So this means that this one is, it gets 9 times more load than one of these other ones gets, and 3 times more than these other ones. Then here it has this application optimized routing. This is going to keep the traffic from a single application or service combine and staying and going into a single WAN. And so that is important to have for a lot of things, so I do leave that on. Link backup I don't typically use, but you can use this because right now I have it just as load balancing. But if you want it to fail from one, if one WAN goes bad and you want it to all switch to another one, you can set that up in here by saying, here's my primary WAN, and then I want you to back up and go to this WAN, and then you can tell it if you want it to switch once and stay on it and not switch back, or does it want it to detect and switch back. So those are some different options you can do, and you can have it if any WAN fails or if all the primary WANs fail. So you can have it so that you have like 4 of these WANs all together, and then say, okay, if all 4 of those fail, then yes, go to this last one, but only as a last resort. So those are some types of things that you can change in here. If I go just to show you some neat stuff, going in here to the reports and the summary, we can see that I had these different time periods where when I was doing this testing, I had lots of traffic going through, adding a lot of bandwidth to all these devices, all at the same time frame. So that's confirming that when I was doing the load balancing, it was sending it at least in some degree to all of the devices there. But you can see this WAN 3 is the one I have a 9 times multiplier, so it gets more of the traffic than some of the other stuff. So that's a little bit of a glimpse into this TP-Link. There's tons of data in here, so I won't go through all of it, but if you have questions, put them in the comments below. I'll try to get to them. Alright, so that was pretty cool. Now, that's not the only way you can do multiple WAN setup. So that's a load balancing setup that I did, but you can also do ones called like failover, and failover means that you have a primary WAN going, and then if it were to fail, and we'll talk about that in a second what that means, it would then switch all your devices over to another WAN. And then they have something called fail back, which means if it detects your primary WAN actually gets back up and unbreaks itself, then they'll send the traffic back over to that one. So I have used that as well a lot, and both of those work. They are more simplified, and the point there on what failed means is most of these routers have something called like a ping detection, and that's where it's just pinging a IP address, like maybe it pings Google and just says, hey, did I get a response? If it gets a response, it says that WAN is not failed, right? It is good. But that has a couple problems, and one of them is with cellular. There are a few times I've seen my cellular connection not dropped completely out, but instead it just gets really slow, or like the upload breaks and it gets 0.05 megabits per second upload. Well, that doesn't do me a lot of good, and it hurts my ability to actually use devices when it's connected to that, but it doesn't detect that as a failure because it does ping. So there is another way you can actually combine multiple WANs, and that is with bonding. So broadband bonding is actually taking all your WANs, putting them in a tunnel, and then that gets sent to a server out, outside your house at some place that provides this service, and then they deconstruct all of this signal and send it out along its merry way. So it's able to use all the different WANs, and then all of them get tunneled to this server, and that's how you're able to aggregate all of the bandwidth. And in that sense, a single device should be able to take advantage of all of the bandwidth. So I guess I didn't clearly mention it in the past, but when I have 6 WANs in load balance, I don't get 6 times the speed on any single device. Instead, you get 6 times the bandwidth, which is maybe a little bit confusing to some, but that means that if I had all 6 devices, 6 of these tablets, in theory, with equal ISPs, if they were doing load balancing, I could have 6 of these tablets all getting 300 megabits per second at the same time. And if I just tested one, it would still only get 300 megabits per second. So for the broadband bonding, there are a couple services out there. Peplink, which I've tested some of their 5G routers, they have something called Speed Fusion that does it. And then there's some other ones like Mushroom Networks, even some app-based one like Speedify that you can sometimes take advantage of and use multiple WANs at once. All of them have their limitations. I don't actually pay for any of them. I'm very interested in looking at them. There's another one out there called Mushroom Networks that I'm kind of poking at to see what can they offer. And my biggest thing is I'd love to be able to get multi-gig speed, because in theory I have it sitting up there in my third floor loft, but I don't have a way to aggregate all those WANs together just yet. So if you have any suggestions, please put them down in the comments below. I'd love to understand if you have ideas of ways I can better use my ISPs I have out there. And then of course, if you have any questions about my setup or what to do, check out the video description. I do put links to the products in there, so if you want to look at them. But then if you have some other type of question, put it in the comments and I will try to get to it. Thanks.